Yes, tell me, what do you already know about nuclear physics? What is it about? What does it deal with? What is it that you have to learn extra?
Take it from the start.
Mm-hmm. Wait, did you say that you didn't even start it yet in school?
Can you take it like from the start?
I will. तुम बताओ तुमको क्या क्या समझ में आया है already? Like, what are we going to talk about? Are we only going to talk about the material that can be used for making an atom bomb, or like something more specific is covered in this particular concept? Most of it. Okay, you remember तुमने chemistry में पढ़ा था that you are going to have this particular atom, right? And we right now when we were doing stoichiometry, we discussed that there is going to be a particular amount of mass that this particular atom is going to hold. Here in this particular chapter, you're again going to be talking about the same thing over. Okay, you are going to learn that, okay, if this is an atom, it does have mass, it does have molecules, or we can call them as subatomic particles. And these subatomic particles are either going to have a positive charge or a negative charge or a neutral charge to them, and each one of them are going to contribute to the or overall weight or mass of this particular atom. We also are going to see that your singular electron is going to have some mass. Okay, it's not that your electrons do not have mass, but the more important part is that although your electrons have a certain contribution that they can make to the mass of a singular atom, the mass of electron is so negligible, it is so less, that even if they are contributing, it doesn't make a massive impact on the mass of an atom. Okay, but they have a huge role to play in the charge of an atom. Okay, it is gain or loss of these electrons that makes a huge difference. Whereas you can just you see one electron being lost turns your singular atom into an ion, okay, where it could be a positively charged ion upon losing electron, and upon gaining electron, it becomes a negatively charged ion. Now, along with this, we also are going to see that whenever you have these, let's say, protons over here and you have your neutrons over here, the number of the protons and the neutrons is also consequential to what happens with these atoms of yours. And what does it mean when we say that, okay, let's say you have this particular atom here with you and it has these number of nucleons, it has these particular number of electrons, but because the energy contained within this atom is very high, sometimes this atom tries to lose that excess amount of energy in order to keep itself balanced, in order to reach that state where it can consider itself to be much more stable than what it originally started off with. This is in the form of radiation, and you are going to see that there are going to be these different kinds of radiations that you will have. There would be something called as an alpha radiation, there would be beta radiation, there would be gamma radiation, and all of these kinds of radiations are actually going to make an impact on how this atom is going to behave. We're also going to see how long it will take for an atom to release all of these substances. Like if I say that my atom is going to release alpha radiation, how long will it release? Okay, will it start today and end tomorrow afternoon? What is the schedule that it runs on? It is very long. Okay, just to give you a gist, it is going to be very long, and in one individual's lifespan you cannot measure it. But what we can do is we can find out the half life of an atom. So we're just going to go over all of these things very quickly. Okay, and you are going to see that there would be a minimum of 6-mark question on nuclear physics. There is at least 6 marks that are attributed to your total grade on nuclear physics. If you're looking at your MCQs, there would be a minimum of 2 MCQs that come that have something to do with your nuclear physics. So it means that it is going to be the difference between you getting an A or a B. So you have to understand, and this is like mostly just theory that you would be going over. Okay, now let's go and understand what are the different things that you have to remember. Now, like I said, this is basically what your atom is going to look like, right? So I have, let's say this is the central most orbit. Then I have the next orbit right here. In the middle, okay, I have something which is called as the nucleus. In this nucleus, I am going to have a combination of subatomic particles that are going to exist. I have something called as a neutron, and I have something which is called as a proton. Okay, now together, my proton and my neutron are going to make this nucleus. So I will write this is my nucleus, okay, which is made up of what? Proton and neutron. In the external most part of this particular atom, I am going to have electrons hanging around. So I have one electron here, I have another electron here, and I will have some electrons depending on whatever kind of atom this is. Okay, so if let's say I had nitrogen, then I would have here 1, 2, 3, 4, right? I will have like 4 of them hanging outside and 2 of them inside. And I will have a specific number of neutrons and protons in the nucleus. Now, once we say that, okay, I have all of these substances right here, what I need to understand is that each one of these, so when I look at, let's say, just my proton, or when I look at my neutron, proton and neutron are by themselves going to have a certain amount of charge. This charge is what makes your atom bulkier or less bulkier. Okay, so if I look at my proton, now you have to remember that these values most of the time are provided to you in the paper, but तुम अगर थोड़ा सा इसको याद रख सकते हो, nothing good as that. Okay, so तुम्हारा ये जो proton है, it is slightly heavier as compared to your neutron. Now, when I say slight, it is actually a very slight difference. अगर तुम्हारा ये proton का mass तुम लिखोगे, it is 1.676 into 10 raised to minus 27 kilograms. Okay, this is the mass of your proton. You can make out it is minus 27. That means it's not going to be amounting to anything much on its own. Okay, when it comes to your neutron's mass is again 1.674. You see a slight difference over here, right? Not a very huge difference in the scale of where you look at this entire pencil. The mass of proton and neutron for this would not make a huge difference if it is differing by just, let's say, 0.002. But when it comes to taking into consideration what it means with respect to your electrons, this is a huge difference for your atom. Okay, this is again raised to minus 27 kilograms. Together, your entire proton and neutron mass gives rise to your nucleus. Okay, now once you have your proton and your neutron together, these sometimes, instead of being called as a part of nucleus, they can be termed together, and you can call these two particles when they are next to each other, let's say like this. This entire subatomic structure will be referred to as nucleon. Okay, so one nucleon is nothing but your neutron and proton together. Okay, now if you look at this, if you have, let's say, one nucleon that is having a particular number of neutrons and a particular number of protons, If I take into consideration another nucleon, so let's say this was my nucleon A, and this is my nucleon B, and this is my nucleon C. All of these guys separately, if I want to talk about nucleon A and nucleon B and nucleon C, then what I will do is collectively, I will use a different word to refer to them. And this word that I would now start using is called as nuclides. Okay, so NuClides. Nuclides basically means multiple nucleons together. This is making sense? Yahan tak you're understanding what I'm talking about? Yeah. Yes, no, maybe, perhaps 10%. Yeah. Okay. तुमको MCQ questions में ऐसे छोटा सा tricky word डाल के they try to get you to select the different answer. Nucleons together are called as nucleoids, okay, or nuclides, however you want to pronounce that. Nucleons are similar to nucleus. It's just that nucleus is a word that you have learned in biology and they didn't want you to find it easier to deal with this particular part. Okay, so what we do is, just give me 1 second. Let me just pull this chair. Yeah. Because they wanted to be something different for you to learn. Now what we do is, instead of calling this nucleus, we call it a nucleoid. Okay, now coming to the next part. When you look at any particular periodic table element, okay, let's say you just simply kind of drew a periodic table and you see in each box there is a particular element that is put. So if I say that this is the element, okay, you will see two different values written next to one another. Each one of these value, okay, the one that is on top and one that is at the bottom, is going to mean something different, and you have to use those values collectively, or you have to separate them out together so that you can identify whether this is the mass number or this is the atomic number of your atom. Okay, remember the one on the top, the one that is given to you on the top, which is A. This is your atomic mass number. Okay, AMN. The Z at the bottom over here is your atomic number. Atomic number. Now, sometimes they could change this. Okay, you may see certain periodic tables where if they write it like this, let's say this is my X, they could give me the atomic number on top and the atomic mass number at the bottom. And I can differentiate between the two by looking at the fact that on my periodic table 1, okay, the atomic number 1 will always be followed by atomic number 2, and it follows a sequence. So I will have 3, 4, 5, 6, 7, 8 going in a sequence like this. Now the mass of these atoms will also go on increasing in the ascending order itself. From left to right, the atomic mass of my elements goes on increasing, but it doesn't increase by one difference everywhere. The difference between the two atomic masses is never the same. In fact, it is quite possible that here you may see the value X, or yahan pe it may be X.5, and here it could be 3X. Okay, so whatever value you have, let's say if X is equal to 1, then 3 ka mass is 1, iska hai 1.5, and if you thought this would be 2, it is not. It is in fact 3. Okay, so it will just go on increasing as the mass goes on increasing. There's no particular logic as to how much it is increasing. So you can just figure out, कि like, अच्छा, ये number तो मेरा mass हो सकता है. Mass can be in decimal points. Number, atomic number is a whole number. Okay, now if you were not given, let's say, the neutron number in a particular atom, okay, so you wanted to find out how many neutrons are present in this particular atom that is given to you. What you would do is, so I'm going to write neutron number. If you are given either of the values, you can find out any other answer for this particular question. अगर तुमको neutron number नहीं पता है, तो you will do neutron number n is equal to A minus Z. Okay. Now, if just simply you wanted to find out which nuclide is bigger than the other nuclide, this is all that you would have to do. You will simply have to find out how much is the difference. Okay. You can also find out the value of Z if A and N are given to you. You can find out the value of A if N and Z are given to you. So this is just like common logical thing that you have to do. Okay, and you can figure out a lot of things about your atom by simply taking this concept into consideration. Now, this X that we wrote over here, okay, so whenever you're looking at this particular symbol, the X value that you are talking about, this X means that it is the chemical symbol of that element. So if I was to write X here, the X means what element we are looking at. So element X. Okay. Then you have the atomic mass number and you have the atomic number. Okay. Now, if you are given any of the values, it contains the information of either atomic mass or atomic number. And using these, you are going to be able to figure out a lot of things. Just by knowing the structure of your nucleus, or just by knowing certain, values about your nucleus, you can make a few conclusions. Like, for example, if you see that there are two particular elements that are given to you, okay, let's call it element 1 and element 2. Now, assume if the number of nuclei, or if the element A and element B, or element 1 and element 2, have the same value for Z, it means that these are the same elements. Okay. So if the number of Z is same, it basically means that you are going to have the same element. But if the value of Z is same and N is not the same, okay, understand very carefully. Value of Z is same. So I will write over here same. And here also I'll write यहाँ पे भी I'm going to write same. If both of the values are same, it is one element. But if the number is not same, then these two would be the same element, but isotopes of one another. So same element, isotope. Is that making sense? So isotope is a substance who has a different neutron number. Okay, this means that they are going to have some quantity that is going to remain conserved, but they are going to have different isotopes. There are many substances that exist as isotopes, and there is a certain amount that we say if it goes beyond this particular amount, it is abundant in nature. So you can find out the natural abundance of any particular substance by finding out what is the percentage of that substance present in the nature. If you find that out, we say that we have the value for abundance, okay, or we can also call it as natural abundance. So natural abundance is percentage of a substance in the nature. Okay, if you find out the percentage of a substance in the nature, then what you have with you is the natural abundance. How will we find natural abundance? They will give you the values of every single thing that they want you to look for, and then they'll tell you in, let's say, 9 moles of gas, let's say 9 moles of oxygen present in the nature, okay, there is, or oxygen ke jagah pe, on this 9 moles of carbon dioxide, there is 3 moles of oxygen. Okay, if this is something that they are telling you, you will simply calculate the percentage and then you will say the natural abundance of this particular substance is so and so. That's very simple kind of questions that you are going to get. Okay, so I will write percentage of a particular element in nature. Okay, yahan tak you're understanding everything. Anything that by far has not made sense, anything that you feel like, okay, maybe we need to go over this one more time. Anything? Pakka, you're understanding this part? I'm going to go and jump onto something really important now. So if you have understood this, only then I will go ahead. Show me thumbs up if you understood. Yes. Okay. All right. Now, once I say that I have all of these properties and using all of these, pieces of information, I can frame together one picture of my atom. Okay. Now we already learned that if an atom either gains or loses the electrons, it is going to acquire a particular charge, and charged atoms are called as ions, right? So if I have an atom that has a particular kind of charge, I am going to go ahead and call it an ion. So I will take one atom here, okay, and I will say right now this is neutral. How is it neutral? Whatever number of protons I have are balanced by the total number of electrons. अगर मेरे पास 4 protons है, तो मेरे पास 4 electrons होने चाहिए, so that the charge becomes neutral, because I have positives that will kind of negate out my negatives. Okay, so like positive को balance करने के लिए मेरे पास उतने ही negatives भी है. That's what makes this particular atom neutral in the first place to begin with. Now comes a trouble. If I say कि मेरे पास एक इलेक्ट्रॉन कम हो गया, बाय okay, एक इलेक्ट्रॉन अगर कम हो गया, तो what I will do, I will have a positive charged ion with me. How did that happen? Because electrons are negatively charged. As soon as an atom loses any negative charge, it becomes slightly positive. So right now, in other words, I could also say that the electropositivity of this atom has been decreased. Or has it increased? Did my electropositivity decrease or did my positivity increase? It increased, right? Why? It became more positive. So I will say electropositivity increased but electronegativity of this atom has gone down. It has lost its negative charge and it has acquired. Now say in this particular concept, the terminologies are very, very important. The kind of jargon you use in this chapter is very important. अगर तुम electropositivity की बात कर रहे हो, you will say this is because of loss of electron. यहाँ पे तुम बोलोगे gain of electron. You can also use alternatively loss and acquisition. Okay, so you can say it has acquired positive charge or it has acquired negative charge. So it has acquired positive or negative charge. Very, very important that you take this part into consideration. Now, when you talk about all of this, okay, again, another very, very important part that comes into picture is how are these electrons located and how exactly does any particular atom go on to gain or lose these electrons. Now, every single time that you look at this particular kind of an atom, okay, if you look at where this atom is present, what is happening with these atoms, it becomes very important for us to identify the part that while this is where my nucleus is present, is nucleus ke aaspaas, I am going to have a singular orbit, which is the first closest orbit to my atom, okay, or to the nucleus. Between this space, starting from the nucleus to the orbit, this blue location that I have is empty space. From here to here, there is absolutely nothing. Okay, this is the empty space. Your atoms are 90% empty space. So now this is where there's a huge paradox that scientists are really still confused about. If I say that this is made up of silicon, okay, silicon is a very large atom, but as large as the atom gets, more space is present between them, because if this is the first shell जहां पे मेरा न्यूक्लियस और न्यूक्लियस के बाजू में फर्स्ट शेल है, सेकंड शेल और फर्स्ट शेल के बीच में भी थोड़ा सा स्पेस है, right? So there's like a certain distance by which my first shell, so let me say that this is my S shell over here, so I will erase this part and I will say this is my S shell, this is my P shell. Okay, so if I have S and P, these are the two shells. The shell numbers or the shell names go as S, P, D, and F. This is the increasing sequence of my shells. So between my S and P, there's again going to be some space. मेरे न्यूक्लियस और S के बीच में भी स्पेस है, S और P के बीच में भी स्पेस है. So the larger my atom goes on getting, more is the space. तो जितनी बल्कि तुम्हारी चीज है, उतनी ज्यादा empty है. Are you understanding what I'm trying to say? The bulkier the atom gets, emptier it becomes. But if that is true, then why is it that the atom is still going to have certain amount of mass? How is it possible that even if silicon, which is such a large atom, when you take several atoms together, it becomes much more stronger, it becomes much more malleable, it becomes much more denser as compared to when you have just hydrogens, which is like less empty space and more electrons per unit area. We still have no good explanation for this fact. But an atom is basically a particular structure where there is a very small nucleus that is surrounded by large amount of empty space. This empty space has very negligible mass containing electron orbiting around it. Okay, and the major mass of this atom is only and only contributed to by the nucleus. Okay, that is the first part. So I will say empty space is the first point that you have to remember. After empty space, you have to remember mass is from the nucleus. Okay, and the third very important part that you have to remember is that your nucleus is the positively charged substance. So nucleus is positively charged. Fourth, mass of electron is negligible, which means what? All of the mass is basically contributed by the nucleus, but charge that is negative is due to electrons. So these are some points that you have to remember every single time that you talk about a structure of atom. Okay, if we are looking at any particular atom here, all of these things are super duper important for us to follow. By either losing or gaining the electrons, the charge of this atom goes on changing, which is exactly why you have to make sure that you have a balanced number of positives and negatives. Now, when you don't have this happening, okay, let's say right now, everything is about one atom. What if instead of having just one atom, you had many of them? You might think, अगर मेरे पास ये एक structure है जिसके पास काफी सारा empty space है, so I'll just say that this is a thing where there's only something present in the middle, and then I have another structure which also happens to have a major amount of empty space with some structures again in the middle. Okay, if I try to combine them together, if I said that I want to take this structure with empty space here and I want to overlap it on a place in this manner, I can only do it till a particular length. I cannot try to fuse two atoms together beyond a certain space, because the positives and the negatives are going to occupy a certain space in that empty location. So I can push my different atom all the way here, but once I get it here, I will notice that it no longer comes closer. Okay, and the reason that it no longer gets together is because these two positives will repel one another. But when I try to take any particular atom and join it together, it is the nucleus that is going to come together, and this particular reaction is called as nuclear fusion. If I have two nuclei already fused together, and if I try to separate them, so I have these here and I just kind of separated them. If I do this, they will release a huge bulk of energy, okay, removing these atoms from vicinity. So they were like this, and then I have made them separate. This kind of reaction, okay, is going to release a huge amount of energy. And this huge amount of energy is released because I carried out another kind of reaction where I just basically, tried to get them to stick to one another, is called as nuclear fission, or I tried to remove them. Okay, are you understanding? I'm going to release the energy by blasting them from one place. So I will have fission reaction take place when I separate them, and I will have fusion reaction take place when I fuse them together. Both the things are going to require energy. This meeting is going to end. I will restart another one. Okay, just give it a second. I get the countdown. Join back on the same part.